link of the recording. I want to continue with the questions you sent to me yesterday. Today we have about how many? Question 2, 3, 4, 5. All right, there are many questions we're supposed to do. Yesterday we did the whole of question 1. Then now let's go to question 2, which say use the graph to find the gradient of each of the following line segment below. So we must be able to find the gradient when we are given a line segment. Line segment is simply a straight line. If you see a line like this, therefore that is a line segment, which is also called a straight line. So now, but on that figure, we are given different straight lines. Let me count how many are they. 1, 2, 3, 4, 5, 6, 7. We are having 7 straight lines. All the 7 straight lines, they have different gradients. So we must be able to read their gradients in this case. So I'll start with a straight line A. I hope you have it with you that side. You have straight line number A, right?
Yes, I have it.
All right, yeah. So I'm going to show you how we find the gradient of straight line number A in this case. So now you must check where that straight line starts and where that straight line ends. So of which in this case, we'll start with the point where the straight line starts. So we're going to use the Cartesian plane with those boxes to count the specific position of the point where straight line starts. So we start by counting on the X, and then from there we'll go to the Y. Remember, we are focusing on the point where the straight line starts. Is that right? I can't be able to write this on the board because it's a bit complete. All right, let me do it this way. So that I can be able to explain this question to you clearly. I have an idea of how we can go about this. So let me download this. I hope you can see my screen now. Is that so?
Yes, I can see it.
Yes. So that is the diagram which I'm going to explain to you. So now we are interested to find the gradient of the first straight line, which is this one. We are interested on this straight line number A. So let me give it a tick there. So now, in order for us to find the gradient of this line, we must find the specific point here, and which is the starting point, and then here we have the end point. So how do we find the coordinate of these 2 points? We find the coordinate by counting on the x-axis. So the x-axis is -1, -2, -3, -4, -5, -6. It's at position number -7. Therefore, the x value, it means is what? Is -7 here, like this. And then from there, you go to the y-axis. So on the y-axis, you count here. So we start from 0, then 1, 2, 3, 4, 5. So therefore, this is aligned to position number 5, like that. Therefore, in this case, we have a coordinate of -7 is to 5. The x value is -7, and the y value is what? Is 5. So let's do the same on this other point that we have this side. So on this other point, you will see that this point is at the position where x is equal to -4. So it means we're going to have -4 here. And then again, it's at the position where y is equal to 5. So then this is how we find the two coordinates.
Then,
Yes,
how are you getting this?
the values.
Yes.
All right, let me explain again how to get this value, because that is what is critical in this specific question. So you see, we are, or let me rub it off so that I start from scratch. You see straight line number A.
Yes.
Yes, all these are straight lines. We have different straight lines, and all these straight lines, they are having different gradients. So, but for now, we are focusing on getting the gradient of straight line number A. So in order for
Yes.
you to get the gradient of straight line number A, you must check a point where this straight line starts. So I believe you can see that this straight line is starting at this point, which I highlighted by red color. Do you see that?
Yes. Yes.
And it ends here, where I also highlighted by red color. So then now,
Yeah.
we have to find the coordinate at this point where it starts. And again, we have to find the coordinates where this point, at this point where it ends, where the straight line ends. So how do we find this point? We use the Cartesian plane. Cartesian plane is this one where we have x here and then we have y. So, and on this Cartesian plane, I believe you can see the blocks. There are blocks
Yes.
inside the straight line. So, and within that block, then we're given the numbers. So here we have -1, -2, -3, -4, -5, up to -9. Going down, we also have -1, -2. And then going to the right-hand side, we have 1, 2, 3, 4, up to 9. And then going upward, we have numbers up until +8. Do you see those numbers?
Yes.
Yes. Those numbers are the ones which are going to assist us in getting the x values and the y values of these specific points that we have here. So now this point, the point is having the x and the y value. So in order for us to find the x value, we must look where exactly is this point aligned to. So I believe you can see that this point here is aligned to the x,
-7.
which is equal to -7. Yes. So therefore, that's why here we have x value of -7 for the starting point. So we also have to find the y value. How do we find the y value? Y value we find by going to this direction now. And then we check where is this point aligned to? It's aligned to what?
5.
To 5.
+5.
Yes, definitely. So we were able to get the coordinate of that first point there. So we now have the coordinate of the first point. Let's do the same with the second point. Let's check the x value on this point, which is the end point. So on the end point, it aligns to the x value, which is equal to what?
-4.
Yes, it's -4 in this case. And then the y value is aligned to what?
+8.
+8. And that's how you find the 2 points. So
Okay.
with these points, we can be able to get the gradient. You remember the gradient formula I gave you yesterday?
Yes.
Yes, let me write it.
And so how do we know? Oh, I found that. I found it.
Yeah, so let's calculate the gradient by using the gradient formula I gave you yesterday. So gradient formula is y2 minus y1
-1 divided by x2 minus x1.
Yes, very true. So this is the formula of calculating the gradient. So after that, we have to name these points. Other one must have x1 and y2, y1, and then the other one must have x2 and y2. So if I say this one is x1, so it's a must that the y value of this, it must be y1, like this. Then if I say this is x2, then it's a must that this y, it must be y2, like that.
Y2.
Yes, very true. Then now let's substitute on y2. Y2 we're going to substitute by what? By 8, right?
Yes, by 8.
Yes, then minus, because we have y1, is it negative or positive? It's negative. It's positive, therefore there's no need to
It's
have,
positive.
yeah. So
-5.
yeah, we just say -5 in that case. So we're going to have -5 like this, and then we divide by x value, which is x2 in this case. X2 is what here?
-4.
It's -4. And then we divide by what? By x1, which is equal to?
-7.
Yes, very true. So this is how we go about it. Then now what is left is for us to simplify. You see why I put the brackets here?
Yes.
Yes, you must know that in this case, we're going to have the brackets because of the negative of the two negatives. So then here we're going to have 8 minus 5, which is 3, and then divided by -4 plus 7. It will be plus because negative times negative is positive, right?
It's positive.
Yes, the
Yes.
-4 plus 7 will give us a positive 3. So therefore 3 divided by 3, the answer for that is 1. Like that.
Yes.
So we now have the gradient of that specific straight line. The gradient of that line is equal to 1. So is it clear to you?
Yes.
All right, wonderful. So we do the same with all these straight lines. So let's try this other one. So I think what is critical is for me to show you how to get the points. And I believe once you have the point, you can be able to substitute and you find the gradient. So let's start with this one. This is the starting point. So if that is the starting point, what can be the coordinate of that starting point by using the Cartesian plane? So that point is
1.
x value of 1, and then the y value?
It's 6.
Is 6, yes, very true. And then on this other one, what is the x value?
7.
Is 7, positive 7 in this case. And then the y value?
It's 8.
It's 8, yes. So this is how you do it. That is how you do it. So you now have 2 points. Once you get 2 points, it's simple to get the gradient. You see that?
Yes.
Yeah, so we do the same with any other questions that we have here. Even on this one, on question number C, so you'll see that we're having -5 is to what? What is the y value of this one?
Of which one?
Of straight line number C.
It's,
So it's
isn't it 4? It's,
yes.
It's -5. It's -5.
It's -5 for x value, right?
Yes.
And then
For
positive.
y, isn't it 4?
Yes, for y is 4. Very true. And then we also check the endpoint. On the endpoint, the x value is what?
It's 1.
And then the y value is 4 again.
It's 4, yes.
So let me show you the other difficult straight line. is this straight line number G. The other ones are simple. You do the same thing. So you can be able to find all these other points. You do the same thing. But here you can see we're having here where I put a small dot. So we're having X, which is -9. So because it's on top of the x-axis, it means y is equal to 0. So it's on top of the x-axis where y is equal to 0. So take note of that statement. It's very important that because it's on top of the y of the x-axis, therefore we're going to have -9 is to 0, and that's all. So that's how you do it. So, and then let me explain this straight line number G, because it's the most interesting one in all the other ones we have here. So you'll see it starts where X is equal to 6. And when X is equal to 6, Y will be equal to what? Will be equal to 2. You see that?
To 6. Yes.
Yeah, we start on this one. It will be equal to.
We don't start on top.
We start at the bottom here. So it's 6 is to 2, right?
Yes.
Yeah, and then we look where it ends. So where it ends, you will see that the X value is again on the same position when X is equal to 6. And then the Y in this case
equals to 6.
Also equal to 6. So let's find the gradient of this. There's a reason why I would want to do a gradient of that with you. So you'll see something very interesting. So the X value in this, okay, let's start with the Y value. The Y value, let's say this is X1, X2, X1, Y1, and then X2, Y2. So the Y2 in this case is 2 minus, and then the Y1 is 6. And then all this must be divided by X2, which is 6, minus X1, which is 6 as well. So if you compute this, you will see that we're going to have -4, -4 over 0. You see that?
Yes.
And any number over 0, we know is what? It's undefined.
It's undefined.
Yes. So why am I saying this? Because you must know that the slope, which is perpendicular to the x-axis. So this is the x-axis. So if it is perpendicular to the x-axis, therefore it have a slope which is undefined. So it doesn't have a slope in simple terms. So you mustn't have a problem with a slope that is undefined. It's only of this line. If you have a line which goes in this way, then it's having a slope which is undefined. And this one, even before I do it, you must know that the gradient of this is going to be equal to 0. So there is no slope. Remember, slope I said is the same. So Jambari, if the line, it goes straight like this, therefore there's no slope in that case. So the slope of that is equal to 0. But this one, which goes this way, is having a slope which is undefined. So it's the only one which will be having a slope which is undefined. Otherwise, the rest, they will be having a proper slope in this case.
Okay.
Yes. So one more thing which I will want to emphasize here is that this line here, this line, and this line, they will all be having a positive slope because it's increasing. This slope is increasing. It's going upward like this. Even this one from here going that side is going upward. Even this one from here going to that direction is going upward. Therefore, it's having a positive slope. But this one, you will see, we're starting here, then it will be what? It will be going downward. Therefore, it's having a negative slope. Yes, even this one is going downward. It's having a negative slope. So on these numbers C and number G, we can't talk about their slope if it is positive or negative, because remember, this is having a slope of 0, right? And a 0 is a neutral number. You can't tell if it's positive or it's negative, because it's a zero. Zero is a neutral number. So we can't talk about the slope of that. Then this, I showed you that it's having an undefined slope. So,
Yes.
yeah. Otherwise, I've interpreted these diagrams for you. So you must be able to read the gradient from the straight line.
What about the other questions I sent you?
All right, let me open the other question. Let me close this one. Open the other question for you. Is this one? All right, these are other questions you sent to me. So it say use a square paper to show straight line graph with the following gradient. That is simple to answer. So what you're supposed to do is just to draw a Cartesian. Okay, let me draw it this side where we have a space. So you just draw a Cartesian plane like this. I don't have a ruler, so it will not be straight. Or maybe let me use this so that it can be straight. Yes, so this is a Cartesian plane. So with this question, what you're supposed to do, you just have to observe if this gradient is positive or is negative. So you see this one is having a gradient of 3, and then this one of 2 over 5, and one of 3 over 2, and this one is of 1. So therefore, all these from A to D, all the gradients are what? Are positive. Do you see that?
Yes.
Yes, they are positive, all of them. So if it's having a positive gradient, what they require you is just to draw a straight line which goes like this. And that's all which you have to do in this case. So, but there's something very interesting which I'll want to show you. You see, this one is having a gradient which is equal to 3, and 3 is greater than 0. So if it is greater than 0, then your line, the line, it must be above the origin. Origin is here, where these two lines, they cross each other. So your line must be above, it must be above the origin. So for the first one, where the gradient is equal to 3, then you're going to have this straight line that we have here. So then now, let's go to B. I'll show you again with B. B is having a gradient of 2 over 5. So if you have a calculator, they just punch this value into your calculator, and then we see if it is less than 0 or is greater than 0.
Okay. It's 0.4.
Is 0. Oh, no, I mean, I wanted to say if it is greater than 1. So if it is greater than 1, it must be above the origin, like what I did here. So 3 is greater than 1. Therefore, this graph, it must be above the x-axis. So, but now, if it is less than 1, like what we have on number B. Number B is 2 over 5, which is 0 point something. Therefore, that is less than 1. If it is less than 1, then it must be below. It must be below the x-axis. Like here, you see, we have an origin here. Then you must draw it below the x-axis, like what we have here. So that is how you're supposed to answer question number B. And this one, which is having a gradient which is equal to 1, the one with the gradient which is equal to 1. So it means it's neutral. It's not above and it's not below. Therefore, it must pass.
What about C, sir?
Yes.
C, the one for 3 over 2.
Oh, yes, for 3 over 2. Let's check. 3 over 2, punch it in your calculator and we see if it is above or below. Is it greater than 1?
Yes, it's 1.5.
Yeah, so in that case, so it means you will draw it somewhere here. Why did I draw it below the first one? Because if you compare the two gradients, which one is greater? Is this one of 3?
The
Right?
first one.
Yeah, so that's why
Yes.
it's here is a bit far as compared to this other one. So you have to draw it above because it's more than 1. Then, but it must be below this one because we find that this is equal to 3, right? So it's above this one for 1 point something.
Do we draw all of them in one graph?
Not really. You can draw them in separate graphs.
Okay.
Yes, draw them in separate graphs because they did not specify here that you must draw them in the same set of axes. So draw them in separate graphs.
Okay.
All right, then we go to number D. For number D, then if it is equal to 1, therefore the gradient, it must pass through the origin because the gradient is not greater than 1 and is not less than 1. Therefore, it must pass through the origin. So the origin is where these two Cartesian plane cuts. Therefore, you are going to have this line for a gradient which is equal to 1. Is that clear?
Yes.
All right. And then for number E, the gradient is not positive and is not negative. It's the same with that other one we talked about. So that straight line, it must go this way when the gradient is equal to 0, like this. So you can draw it anyway. You can draw it here or you draw it that side. It doesn't matter because the gradient is equal to 0. Even if you write it down here, it will be fine. There's no one who can mark you wrong. As long as the gradient is equal to 0, then that line, it must be parallel to the x-axis at all time. Then question number F. Question number F, it's having a negative gradient. So, and this negative gradient is -1. Remember, for 1, it must pass through the origin. If it is -1, it must pass through the origin. Therefore, in this case, you are going to draw a straight line which goes like this because the gradient is what is decreasing. It's negative. You see that?
Yes.
Yes. And then from there, we have this one of -half. Let's check if 1/2 is greater or less than 1.
1/2. It's -0.5.
Yes, -0.5. You plot it below the x-axis like this. So if it was above 1, maybe -2, you're going to draw it somewhere up here. But now it's below 1, therefore you must draw it down there on this thing. Is this 6 questions clear to you?
Yes.
All right, wonderful. So the last question is the simplest, but it requires some attention. Let me show you how you go about this question. So it said the petrol consumption of a car is presented by the graph below. So that's why I showed you gradient is very important. You see, they are now talking about the petrol of a car, which represented by the graph below here. So we can know when exactly this car is going to start because when a car travels certain distance, then the petrol, it will be what? It will be reducing in that case. So let's check the first question they require us to answer here. They say, determine the number of liters of petrol the car will use when it travels a distance of 75.
75.
Yes, definitely. So we can check that by observation. We have to observe like what we did when we wanted the coordinates of the gradient in the very first question we did today. So you go and check, where do we have 75 kilometer? Remember, this is a petrol used, which is in liter, is on the x-axis. And then on the y-axis, we have the distance traveled, which is in kilometer. So we are told that this has traveled 75 kilometers. So
5 kilometers.
Yes, we must go and check where we have 75 kilometers. For sure, 75 is between 72 and 80, right? It's somewhere at the middle.
Yes.
Yes, you go and check where does it intersect the graph. Remember, this is the graph that is given. So you check where it intersects the graph. So where it intersects the graph, you join and instead you then go down and see where it's going to intersect the x-axis. So you go like this. So it's going to intersect the x-axis somewhere in between 7
and 8.
and 8, yes. So therefore, if this car travels 75 kilometer by this straight line that you are given, it means it's going to consume 7.5 liter.
And yes.
It's going to consume 7.5 liter like this. So we have answered the first question. Is it okay?
Yes.
All right. Then now let me go to the next question. Let me see how I can wrap off this. All right, so that one is going to have, is going to travel when it travels,
25.
yeah, 7.5 liter when it travel 75 kilometers. So we have answered the first question. Then let's go to the second question. So the second question, it says, what is the gradient of the line of this line? So gradient of the line, we calculate it by using information from the straight line. We check where it starts, where this straight line starts. So this straight line, it starts when x is 0 and when y is what? Is 0. Is at the origin, right?
Yes.
So it starts when x and y, they're both equal to 0. And where does it end? So it ends when x is equal to what?
10.
Equal to 10. And when y is equal to?
10.
Yes. Hello, you're back.
Yes, I'm back.
All right. So I was talking about the end point here. So on the end point, we have x, which is equal to 10, and y. What is the value of y in that case?
100.
It's 100. Very true. So then now let's substitute into the gradient formula, of which I believe you now know. So we're going, let's say this is x1 and y1, and that is x2 and y2. So y2 is 100, and we subtract with y2, which is 0, and then we divide by x2, which is 10, minus x1, which is 0. So therefore, we're going to have 100 minus 0, which is 100, divided by 10 minus 0, which is 10. And therefore, in this case, we're going to have 100 divided by 10. And the answer of this
Is 10.
So it's having a gradient of 10. And there are a lot of things which this gradient it tells us. That's why it's important to calculate the gradient. I'll explain more with regard to what the gradient means. So let's go to the next question. So it says, what does the gradient tell you about petrol consumption in liters per 100
kilometers?
Yeah, unfortunately, they are asking you about what I was telling you on this question number B. So that the 10, this gradient of 10 means a lot. And they want us to answer of what it tells us. What does this 10 tells us on this gradient? All right. So in simple terms, this gradient of 10, it simply tells us that this car is going to consume a lot of petrol. When it travel certain kilometers, for an example, in this case, if it travel 1, it's going to consume, if it travel 10 kilometers, it will consume 1 liter. If it travel 20 kilometers, it will consume 2 liter and up to so on. So the interpretation of this gradient, it's simply to say that when it covers high distance, increasing of a distance will interpret to say the car will consume a lot of petrol. Let me write that down here so that you see what I'm talking about. I'll write it in text form. So increasing of a distance implies the increase in petrol consumption. How do we came to that conclusion? We came to that conclusion because the gradient is positive in this case. So if the gradient is positive, it tells us that to increase the distance, therefore that means the car will consume a lot of petrol. So the increase in distance implies the increase in what? In petrol consumption. Because the gradient of this specific line is what? Is positive. We find the gradient to be 10. Is it clear to you?
Yes.
Yeah. So I wish we had another question where we had a negative gradient. So if we had a negative gradient, it was going to say the decrease in distance implies the decrease in petrol consumption, something like that. So, but that's what we interpret with the gradient, that if it is positive, it means the increase in distance implies the increase in petrol consumption. So let's go to the last question, which say if the car's petrol tank has a capacity of 65 liter, what is the distance will the car possibly travel on a full tank? All right, let me get a new script so that I explain that part for you. It's another important question. So this is how we do this question. On this diagram, we are told that if a car travels 100, let me get thick pen. If it travels 100 kilometers, then it's going to consume 10 liters. So that is the information which is given from this diagram. If it travels 100 kilometers, it's going to consume how many? 10 liters. Do you see that?
10 liters.
Yes.
Yes.
So then now the question is, say if the car petrol tank has a capacity of 65 liters, in other words, we are given that if it is saving 65 liters, which is not there in this diagram. So the question requires us to find the distance. What distance could the car possibly travel on a full tank? So we want to identify an unknown value. So we want to know how the distance which it will travel if it's having a tank with a petrol of 65 liters. So you have it this way. You write the information which we know, of which in this case, if it travel 100 kilometer, it correspond with 10 liter. And then now we want to find the distance when it is saving 65 liter. So you do it this way, you cross multiply. So you cross multiply the information with, with the information with. So you multiply 100 with 65. What do you obtain when you multiply 100 with 65?
I got 65,000.
That is 65,000. All right, then 65,000 you equate with X. When we multiply with 10, we are going to get 10X. So, and then from there we make X the sum of the formula by dividing both sides by 10. So if we divide both sides by 10, so it's going to be 65,000 divided by 10, which is what? What is 65,000 divided by 10?
65,000 divided by 10. It's 6,500.
6,500. So it means this car, if it is having 65 liter, it will travel 6,500 kilometers. That's how we answer the number D.
Okay.
Yeah. Ask me where you did not understand before we wrap up for the day.
I understood everything.
Oh, all right, wonderful. So otherwise, let's end here for the day and enjoy the rest of the day.
Thank you, you too.
Thank you.